First of all, I'd like to thank the CCEW staff for all the help they provided during this project. They've put in a lot of long hours, in particular our fellow Susan Mooring. I'd like to thank her for the work she's put in. We really couldn't have done it without them. This has been a particularly exciting project because it's the first in a partnership between CCEW and Ames National Laboratory in Ames, Iowa. We've had the privilege of working with Ames and with the Trima Products, who's the manufacturers of Galfenol, in order to provide recommendations about the direction of their technology. This project has also been great because of the amazing interns I've had the privilege of working with. They're from all across the university, from engineering, from business, from journalism and mass communication. They're truly some of the smartest people I've ever had the privilege of working with, and I've enjoyed the time I've gotten to spend with them. From late nights at the CCEW office to mid-meeting trips to Chipotle or Sonic, we've not only worked really hard this semester, we've also had a lot of fun. I couldn't be prouder of the work they've done this semester, and I can't wait to see what they do next. So it's my privilege to introduce to you Cole, Tahara, Bryce, and John, Team Galfenol.
Each year, upstream oil and gas production companies lose over $5.4 billion due to unplanned downtime. In order to decrease this downtime, production companies are looking into remote monitoring solutions that will allow them to react immediately when something goes wrong at their well sites. Unfortunately, finding cost-effective and reliable power sources for these remote monitoring systems is very difficult. Galfenol, a new vibrational energy harvesting smart material developed at Ames National Laboratory in Ames, Iowa, can provide the cost-effective and reliable power source that upstream companies need to monitor their wells. This semester, my teammates and I have had the privilege of working with the Trima Products Incorporated, the sole producers of Galfenol, to come up with a commercialization strategy for this new technology. We started off with over 10 promising applications in over 30 markets before we narrowed it down to our target application and market in oil and gas. We have also reached out to upstream and midstream oil and gas companies as well as industrial automation firms to gather information and create contacts that Trima will be able to use as they move this technology to market. My name is Cole Jackson. I'm a senior industrial engineering major from Edmond, Oklahoma.
I'm Tahara Taki, a junior public relations major from Tulsa, Oklahoma.
I'm Bryce Hermson, a sophomore chemical engineering major from Chicago, Illinois.
I'm John Warden. I'm an entrepreneurship senior from Tulsa, Oklahoma.
We're joined today by our team leader, Sarah Shapiro. The inventor of Galfenol is Dr. Thomas Lagrasso at Ames National Laboratory, and our company mentors, Eric Summers at Trima Products Incorporated. We would also like to say a special thank you to Todd Starkowski, the program manager for technology transfer at Ames National Laboratory, who is here with us tonight. In the United States, there are over 674 operational oil and gas wells. But due to inadequate well site monitoring technologies, oil and gas companies are losing over $5.4 billion annually due to unplanned downtime. And traditionally, in order to monitor these wells, upstream companies send employees called pumpers out to the well sites to collect data like pressure, temperature, and flow rate, which are early indicators of when something is going wrong. But in remote and very spread out oil fields like this West Texas oil field, continually sending people out to well sites becomes very cost and time intensive. So upstream oil and gas companies are looking for remote monitoring solutions that will alert them immediately when something goes wrong so that they can react and decrease their downtime. Unfortunately, finding a reliable and cost-effective power source for these remote monitoring systems can prove to be very difficult. Galfenol, a vibrational energy harvesting smart material developed at Ames National Laboratory in Ames, Iowa, can provide the reliable and cost-effective power source that upstream oil and gas companies need to monitor their wells. A Galfenol vibrational energy harvester can be integrated into a wireless sensor node. This vibrational energy harvester will harness the previously wasted vibrations from the vibrating equipment at well sites to provide power for sensing nodes that will collect data and alert oil and gas companies immediately when something goes wrong so that they can react, decrease their downtime, and ultimately save over $32,000 per year per well. So let me tell you how Galfenol works. A force is applied to a piece of Galfenol metal. This force realigns the crystalline structure as well as the magnetic dipoles. This creates a magnetic flux. Now, under an oscillating force like vibrations, these changes in magnetic flux could be harnessed using a coil of wire and turned into usable electricity. That electricity can then be used to power sensing nodes like this one. A typical Galfenol-powered sensing node will have a Galfenol vibrational energy harvester that will harness those vibrations from the surrounding environment, turn them into usable electricity, and power the node. It will also have a wireless transmitter and a wireless receiver, as well as a sensing mechanism that will collect the data that oil and gas companies need to monitor their wells. These sensing nodes can then be applied at well sites. They could be placed on wellheads where they'll harness vibration from the artificial lift equipment or from the fluid flowing through the pipes. They could also be placed on the natural gas motors and pumps that are present at most well sites. They will then be able to harness the vibrations, power themselves, and transmit data wirelessly to routers wherever the oil and gas company needs to be able to react immediately when something goes wrong and ultimately decrease their downtime. Now that you've heard how Galfenol-powered wireless sensor nodes can be applied in the oil and gas industry, I'll turn it over to Tahara to tell you about our target market.
Thank you, Cole. So now that you've heard about Galfenol and what it can do, let's look at the initial market. The best initial market for Galfenol-powered wireless sensors are upstream oil companies. This market has a total market revenue of over $287 billion in just the United States and is growing by an annual revenue growth rate of 1.4%. These oil companies are also spending $600 million on wireless sensing options for these oil wells. In the United States alone, there are over 674,000 producing oil wells. In 2013, there are an additional 20,000 new oil wells drilled in the United States. Oil companies invest their time, money, and technology on these new oil wells. 20,000 new oil wells equates to over $8.5 billion in market revenue. Of these 20,000 new oil wells, about 11% were drilled by the top 5 oil and gas companies. The remaining 89% were drilled by smaller, independent upstream oil and gas companies, such as Red Hawk Resources and Mac Energy. Oil companies would be interested in this Galfenol technology, but these small, independent upstream oil and companies are looking for a small and relatively inexpensive way to wirelessly monitor these oil wells. So now that you've heard about the market, let's look at why these oil companies would want to purchase a Galfenol-powered wireless sensor compared to other sensing options. We compared Galfenol-powered wireless sensors to 4 other sensing options. These include wired sensing, solar-powered wireless sensing, other vibrational energy harvesting, and battery-powered. We outlined 4 options that are important to the upstream oil companies. These include range of applicability, the lifetime of the sensing option, the initial cost, and power density. Range of applicability looks at the availability of the power source as well as the durability of the sensing option. Galfenol-powered wireless sensors are widely applicable, as they would have that reliable vibration necessary in order to power the Galfenol sensor. Galfenol sensors are also durable and can operate within harsh environments. These other sensing options may not have that necessary power source that would be needed to power the sensor, whereas the vibrations would be available for a Galfenol-powered wireless sensor. Looking at lifetime, you can see that Galfenol-powered wireless sensors have the longest lasting lifetime within the wireless sensing options. This is especially important as a typical oil well has a lifetime of about 20 to 30 years. Purchasing a Galfenol-powered wireless sensor is especially beneficial to those upstream oil companies as they are looking for a device that they do not have to replace, which would increase the cost. Looking at initial cost, Galfenol-powered wireless sensors are relatively inexpensive or similar in price compared to the other sensing options. This is especially beneficial to those small, independent upstream oil companies as they are looking for a relatively inexpensive way to wirelessly monitor their oil wells. With power density, Galfenol-powered wireless sensors have a little bit lower of a power density, and this would mean that these Galfenol sensors would send data per minute rather than per second. So although the power density is a little bit lower, this is more than enough to send the data that these oil companies need. So now that you've heard about the large, growing upstream oil industry and where a Galfenol-powered wireless sensor would fit within this environment, I'll hand it over to Bryce so he can talk about where a Galfenol-powered wireless sensor fits within the business model.
Thank you, Tahara. We will be recommending that Atrema Products Incorporated partner with a major industrial automation firm, such as ABB, Emerson, or Honeywell. These companies typically sell complete wireless sensing networks, including a wireless sensor, a communication hub, and the software required for the communication to the upstream oil companies. In our case, we will be marketing to smaller companies such as Red Hawk Resources or Crimson Energy. Now, we will be recommending they partner with these major industrial automation companies because these companies provide connections to this fragmented market. They have been working with these oil companies for many years, which will allow them to distribute the product and find customers very easily. Furthermore, they have a proven track record in the market as they've been operating within the wireless sensing industry for many more years. And finally, they would help alleviate a concern that we found talking to oil companies. When we spoke with Exxon as well as some other companies, they expressed a major concern with liability. And by partnering with a major established firm, such as one of these automation companies, they would be able to alleviate this concern right off the bat. So now let's see how this would work. Atrema Products would be selling a sensing node to the major industrial automation company. These companies would then turn around and sell those sensing networks I spoke of earlier to the upstream oil companies. The revenue the industrial automation company could expect to see would be $250 per well site. This includes the software costs distributed amongst an average-sized company's wells, as well as the sensing nodes themselves. Subtracting the software costs and accounting for the 50% markup typical for this type of distributor, we can expect Atrema to return $160 in profit per well site, in revenue, per well site, and $90 in cost per well equate to $70 of profit per well. So now that we've seen that they can profit at this point in the value chain, let's take a look at why they're well suited to this point. Atrema are the sole producers of Galfenol and have gained over 10 years of experience working with the material. This means that they will be able to design better products more rapidly than any of their competitors. And furthermore, they've already completed all of the basic research required to make a vibrational energy harvester. This means they can move directly into the product development phase of R&D. This will save them both time and money compared to their competitors in the market. And finally, their partnership with Ames National Laboratory will not only provide them valuable expertise, but better access to critical information coming out of the labs, as well as credibility, as they have been working with a national laboratory for over 10 years, as well as the United States Navy, using Galfenol. So now that we've seen why they're well positioned to profit at this point in the value chain, I'm going to hand it over to John to talk a little bit about how they can see revenue from this business model.
Thanks, Bryce. So let's take a look at how Atrema will be impacted by selling these wireless sensing nodes. We were able to estimate these cash flows by using two specific companies, Blade Logic and Vensis, along with our conversations with smaller upstream oil companies such as Red Hawk Resources and the huge players in the field such as Exxon and Shell. Initially, Atrema will spend approximately $375,000 in upfront costs. They will recoup this investment in just over 3 years, and they will have a total profit of $1.8 million, or a 380% return on their investment. So let's take a look at how this plays out. As you can see from the graph, Atrema will spend this $375,000 in R&D costs in year one. Although they've already spent 10 to 15 years of working with the material Galfenol, this R&D cost will go toward the sensor node design itself, customizing the frequencies for individual machineries. By year two, Atrema will start their pilot program. This is where they will partner with one or two upstream oil companies and test the reliability and workings of the sensors. This will equate to 1% of newly drilled oil wells, or approximately 210 wells. By year three, the industrial automation firms that they will be partnering with will be distributing the sensors for them. They will be able to penetrate 3% of newly drilled oil wells, which is approximately 610 wells. This will be, realistically, this will be approximately 5 companies that Atrema will be dealing with. This trend of acquiring newly drilled oil wells continues through year 5, where they will eventually have 9% of newly drilled oil wells. In year 3, along with acquiring newly drilled oil wells, they will also be able to acquire already established wells. The reason that they will be able to acquire these already established wells is that the pilot tests will have shown the reliability of the nodes. Companies that don't currently have monitoring systems in place because they can't afford it will now have a cost-effective solution with Galfenol wireless sensing nodes. And finally, companies that already do have monitoring solutions in place will have had the time to retrofit their old wells. By penetrating 0.5% of already established oil wells, Atrema and these industrial automation firms will reach approximately 3,000 companies. This will be 3,000 wells. This will be 30 companies that they will be dealing with. This trend of acquiring new and already established wells continues until year 5, where they have 1.5% of already established wells and 9% of newly drilled wells. ultimately leading to a $1.8 million in profit and a 380% return on investment. Now that we've seen how the financials work out for Atrema, let's take a look at their next steps. After we finish our consulting with Atrema, they will continue their R&D. This will include the sensor node design and basic beta testing to check the frequencies for individual machinery. They will then need to set up their operations. They will need to create distribution channels to get these sensor nodes to the industrial automation firms. Additionally, they'll have to scale their manufacturing, the actual manufacturing of each node. And finally, they will have their pilot tests. They will partner with one or two upstream oil companies, and their first orders will finally be received. Today, you have heard about a problem in data collection services in the upstream oil industry, and how Galfenol wireless sensing can solve this problem. You have seen how Galfenol wireless sensors are better than all other wired and wireless options. You've seen how Atrema will partner with an industrial automation firm to enhance their market penetration and increase their profit. And finally, you have seen how Atrema will make $1.8 million and how Ames' new invention will finally come to commercialization. It's been my team's pleasure this semester to be the first CCEW team to work with Ames National Labs and Atrema Incorporated, and to bring this commercialization plan to them. And at this time, we'll open the floor for questions. So the question involves how we chose upstream oil and gas companies for our ideal market.
So we started off with the 30 different markets, and in order to narrow this down, we looked at the market size and the market growth. We also contacted industry experts as well as potential consumers because we wanted to ensure that this would be a product that they would purchase in the future. From these 30 different markets, we narrowed it down to these 6. And these 6 were based off ideal criteria, which would be that they would be in a remote location, that they would be accessible for a Galfenol device, and that they would need this product. And so from these 6, we then looked at the market size, and so from that, and with a combination of the market growth, we narrowed it down to upstream oil companies as the best option.
So the question involves the value chain with the industrial automation firms and $250 in revenue, and with whether that will cannibalize the value.
These sensors will fill a niche that has other sensors in it, but they're more apt for sensing situations where there are not other good power sources. So it won't cannibalize very much onto their other sources because the idea is to provide a power source where none are available. And furthermore, by providing a Galfenol-powered sensor, they have an edge on their competitors. So we feel that they would still be interested in the product, even though it's a market space that does have other potential lesser solutions.
The question involves is there any waste products with the sensors, and if there's any regulations that would
Galfenol is an iron alloy with gallium, and neither material is toxic, so you could put it into a scrapyard like any other metal or even recycle it if you had a specialized facility. So generally, no, there are not any environmental concerns.
That is correct. So the question involves what Atrema and Ames have been doing for the last 10 years with Galfenol. So right now, in the world, China owns most of the critical materials in the world. So the Navy and Ames created Galfenol because it's iron and gallium, which are not rare earth materials. So Galfenol was originally designed for Navy uses, and this is the plan to bring it to commercialization outside of the Navy use.